Okay, let me see here. So the biggest challenge I've had tonight is actually arranging the screens here. So we'll see, right, how this all works out. This is always my deepest fear, is that I'm going to be like, oh no, it's on a different screen. I can't get it arranged properly. So before we go into that, I just want to introduce myself. Like Dave said, I'm Kyle Davis. I'm the technical marketing manager. Just a weird title for what I do, but one of my things that, the way I like to describe my position is I basically get to work for Redis Labs and try the new cool stuff, and when people, before most people see it. And tonight we'll talk about RediSearch, which is a search engine powered by Redis. I'm not the creator of RediSearch. I like to think I'm not the father of it, but I'm an uncle. I've been there since it was born. I influenced it as it went along, and I've had an important thing, and I talk about it a lot. So I think uncle of RediSearch. The other thing I want to point out is RediSearch, not RediSearch. I say that because that's an often mispronounced thing. I don't work for a company called Redis Labs, or Redis Labs, yeah, Redis Labs. Somebody thought that was actually like construction, like slabs. So
Red is Labs.
Yeah, Redis Labs. That's another one. You know, so it is RediSearch. It was created by my friend Devere. Devere was with the company for a long time, and then he got a great job at a different company doing some really cool stuff. So we've taken the mantle of continuing the development of it, and you know, he left it right at the end of. He's like, I want to get it through to 1.0 and GA. That's where we're at right now. We're actually at 1.2. And so it's a new product for us. Redis. Who here has used Redis? Like, raise your hand, right? A few people. Okay. Who has used a search engine before? Not like Google. Like another search engine type database product. Okay, great. A few people. Okay. So I'll provide some context to it as we go through, and I'll go through demos as well. And we'll do questions at the end. If you have something that's like burning, I don't understand, whatever you just said, just raise your hand, and during the course of the presentation, we'll keep going. The thing that I want to talk about today, and this boy not very good in this sun, but this is beyond key value with Redis. Redis is an in-memory data store, in-memory database that is of the key value family, which means that everything in some way is associated with some key. So you would search, you know, first name, awesome presenter, Kyle Davis, right? That's how you would find things. And then we have structures on top of that. The structures are things like sorted sets. The structures are things like sets, hash maps, those sort of things we can do. The one thing unique about Redis is we are natively in-memory based. What we can do is we can manipulate down to the bit level. So if you want to change one bit in the middle of a 500 megabyte blob, we let you do that. And we can do that at speed because we don't deal with disks natively. We have disk persistence, but when you're interacting with Redis, you're directly interacting with actual silicon, memory, at all times. So to scale out, we use clustering. And clustering involves taking nodes and shards and then dividing out the key space among those things, right? So this is where we descend from, but RediSearch takes it way beyond that. So the way RediSearch works is it's got a few different things, it's got a few features to it. Some are connected to each other and some are not. So RediSearch can do basically three things. Search and aggregation, and I use a Venn diagram here because they both use the same query language. We have our own query language for RediSearch. And then we also can do an autocomplete engine as well. So if you go and type ahead type stuff, you know, you type in the search engine and it says, okay, you probably need this or that. That's autocomplete. And that one's separate because it doesn't actually use the same storage method. In RediSearch, you have an index that you've created, and the index contains all the documents. And the documents you can search in various different ways in the query language. The autocomplete is separate. It's in a separate category, so you can do different things with that. It's intentionally separate because you might have different contexts in which you want to do autocomplete, right? You might have autocomplete for addresses, let's say, and something that's related to, and we'll be using it in one specific data set. But you might also have a name autocomplete, so it makes sense that you would have separate autocompletes. Okay. So just the data lifecycle and search and aggregation. You create a schema, which is pretty normal. Now the one thing that you have to understand, Redis is a NoSQL database. Most of the time you don't create a schema, and it makes it unique because you create schemas here. And you have 4 different types that you can use: numeric, text, tag, and geospatial. they're all kind of like first-class citizens here. So you can do anything with all of them. When you add documents in real time, that's the other thing, since we're natively in memory, everything is real time. So we make it from adding to the index to queryable in 1 millisecond. So that's a really important thing. If you look through the documentation of a lot of search engines to say real time, they got a little asterisk and they define real time, and sometimes some search engines do define real time as up to 30 minutes, which to me is the antithesis of real time. So, real time is 1 millisecond. You can add them directly. You can say, okay, I want to add documents in. You can do it from a hash object that's existing in Redis. And let's say you have a bunch of hash objects, which are hash maps in Redis, and you want to go ahead and add them in. Sure, that's great. Or the other thing that's interesting you can do is you don't have to store the documents at all. You can just add them as an index only. So you don't actually store the content. And let's say you have a very large database that you want to have a search engine on, but you already had it somewhere else in some slower database, right? You just want to have a really fast search engine. Well, that's fine. You can just index only, and then you have that you can go and reference by like a specific like primary key or something along those lines, right? So if you have that allows you to have a really fast index in memory where it's expensive. We all know the memory is expensive, and then slower disk-based stuff where you store the documents. So then on top of that, after you add documents, you can search and aggregate. And you can do that iteratively. So you can add a document and then search, add a document, search again. So it's not like direct phases. So that's kind of the general life cycle. Of course, you can delete documents, of course. That's the whole thing. And if you want to get rid of everything, just drop the whole index, right? So this is basic stuff. This is what you can effectively do. Yeah, you had a question?
You support secondary indexes?
What's that? Yep. Secondary index is the way you can use it. So you don't have to actually store the data. You can, you have your own primary key somewhere else, and that sort of thing. So, and we'll get into that a little bit more. So I'll show you. So let's talk about just search and query real fast. The query language, one of the things that people talk about is, why did you create your own query language? Why isn't SQL or SQL? Well, there's so many problems and so much years have got on top of it, and then people start thinking in joins and things like that. And that's one thing that we are not. It's not a relational database. Get that out of your mind. It's a query language, but it's not relational. So you have one thing that you cannot relate anywhere else internally, so you can't do joins and that sort of thing, right? So we intentionally wanted to change people's mind and start querying it. We didn't want them to fall back on SQL. And you'll start realizing like it's going to look a little bit like SQL. You're going to be able to transfer some skills, but it's different, potentially different. So, and you have familiarity. And the nice thing about it is because we don't have like administrative uses and there's no way that you can actually go ahead and doing damage, it's exposable to end users. So if you just wanted to go ahead and make this search box on the website and then just put it in, you can do that. There's very little damage you can do. Obviously, anytime you accept user input, you have to always assume that it's going to be malicious, but generally exposable to end users. We want to make something that was pretty simple. Intrinsic to search engines is that you don't really have to understand the underlying data, right? So with a search engine, unlike SQL, when you're going through and making SQL query, you have to really intimately understand the data. You can just type in a single word and it will find things for you. It might find too many things, but that's okay. But then we have, on top of that, a power that you can have and find things and zero in on things. So both exposable to end users and very simple, no knowledge of the underlying data to be able to use it. And it needs to also be able to be completely powerful and find lots of different stuff. So let's go over the query syntax. I'll give you an example of what we can do. This is the and, or, exact phrase, geospatial, tags, prefix, number ranges, optional terms, and more. I just rattled this off because I'll give you an example here. So let's say you're looking for a car and you have a search engine that you're trying to find cars in, right? So you could type in something like Chevy truck, right? And it would probably find something close, a Chevrolet truck. However, you can also start doing more complex queries. Let's break this down. So can everybody see this? Okay. So I'm going to go say something starting with CHEV, asterisk, so that will find anything starting with that, or Ford, so this would find Chevrolet or Ford. I don't want to find Explorers. The negative operator here says no, that's a negative. Optionally, the little tilde is a truck, so hey, that's great. Like a truck will be higher in the result set. Year, I want to be between 2001 and 2011, so that's a numeric range. location between 100 kilometers and 7440, so that will find it within a radius. And then a condition tag of good or very good. So that would be something that would be more of a machine type of metadata. So then you would be able to zero in on these things. But you could also type in, 2014 Ford Explorer, and it's probably also find it, right? Depending on the data and stuff. So as you can see, you can have something that complicated, which is approaching some pretty large complexities, but you don't have to, right? That's the goal. That's the trade-off we're trying to make, is to be able to do both. And then you can also do simple full text stuff, like I said. On this slide, let's talk about actually what full text search, what some things you might need. Sorry about that. So stop words, everyone knows stop words are? Stop words are where you take out common words that are not very useful in search context. So a fox in the woods really would only be indexed as fox woods, right? Those are the only two ones, because a, in, and the are something you just don't really, are not really relevant most of the time when you're searching. Then stemming, this is like if you're using you find the word, if you're querying for going, you're also going to find going, go, and gone, right? Pretty simple stuff. Stemming is basically tied to language, right? So if you go through and you have stemming algorithms, we use one from the package called Snowball, and they integrate a bunch of different ones in it. These are all the languages we support. But obviously, if you take something, and I speak Swedish, so if you have Swedish and you try to run an English word through, it's just going to turn gobbledygook because you have different linguistical terms or linguistical parts of the words. So you have to be able to specify which one it is. So we have a wide variety of languages. We certainly don't cover all languages, but one that we do cover that is kind of important is Chinese. Chinese has really specific rules for stemming that are unlike most languages that are on this list. So that is a separate one that's not included in Snowball. That's a different package that we use for Chinese specifically. Slop is a cool feature that you have. Slop is where you're trying to find, let's say you want to find an exact phrase, but you specify a slop. So if you query a glass pitcher with a slop of 2, it would find glass, gallon, beer pitcher. These two being the operative words that we are considering not really that important. So as long as you have glass and pitcher, it would find anywhere in between. So it would also find glass, gallon, pitcher, right? Because the slop is a maximum, right? So we're doing all those optimizations without you knowing about it. So you can query without content or with content. In this case, if you search for it to be or not to be, you could just say, tell me which play it is, and that would say Hamlet, instead of returning the entire contents of Hamlet back. Then we can also do things like just the particular parts that we want. So same idea, if you're doing to be or not to be, we can highlight, so Hamlet, and we're putting, in this case, a bold tag, an HTML tag, highlighting only the phrase that we searched for, so you can find it, and it's only returning part of the play, right? If you're looking through Shakespeare's full works. Excuse me, I got a frog in my throat. And then synonyms. We have the ability to define your own synonyms. So, for example, let's say that you wanted to find that Bob is equal to Robert, so then when you search for Bob or Robert, you're going to come up with the same documents, right? These are some challenges that you have when you're trying to search for different things that you may not really start thinking about until you start digging into it. If you just like searching through words and tokenizing things, you're not going to have these things, and that's what makes a full text search kind of useful. And there's more pizza. If somebody missed out on pizza, it's over there. I'll let you know. So the fun part, the demo. First, I want to toot my own horn and say I'm a very brave person. In the Vancouver airport yesterday, I wrote something, and this is the first time that I've actually shown it in front of a bunch of people. So cross your fingers and hope that it works. This is just what I'm showing today is RediSearch, but I wrote a little envelope around it to make the demo a little bit nicer. Okay, so let's see here. Get my cheat sheet. Okay. Oh, come on. It's always this way. All right. I have a backup, like every good person. Okay, so let's do some actual searching, right? And let's start with the geospatial search. And of course, I copied and pasted things because I wanted to prepare. So, can everybody see that? Is that too small to see? A little small? Yeah, a little small? Make it a little bit bigger.
A little bigger.
That better?
Yep.
Okay, that's legible to everyone? Okay, so what I'm doing, I have preloaded a database of 121,000 building permits from actually the town I live in, like Edmonton, Alberta, and they have an open data policy, which is really great. Like open data cities are fantastic if you're trying to find data sets. So it has all building permits from 2008 until 2018. So if someone says, I want to do something to my house, then they have to put a building permit in, and it's updated frequently. So about 121,000 documents, and they've got every feature that Redis has. It's like RediSearch has. It's like it's made for it. So yeah, Redis uses its own protocol. It uses a protocol called RESP. It's in 250 different client libraries, so probably any language you're using has one. In this case, what I've done, this is called ROS, Redis over WebSockets. This just allows me to like demo things and not show a CLI interface, which is this is for my own very selfish interests. So what I'm going to do here, I'm doing just a Redis search of the permits database. And this is the query language directly. So I'm doing location, and this is the location that I'm centering it on. So this is the longitude and latitude, or reverse, I don't remember the order. I can never remember those. Like lat long. This is long lat, because they do it opposite in Redis. I can never remember, it's my own limitations. The 2 kilometers of this, I'm just going to do limit 085. That's where I was talking about it kind of like looking pretty familiar to the SQL folks. So as we can see, it's bringing up the results. So this is the actual query that was executed. So you can see it's pretty similar. I just did a little bit of a thing around it. So we got a lot of results here. This is just the first, this is 883 results, and I'm only showing the first 85. So
This is the exact location, or this is a range of?
yeah, this is a radius from that 1.2 kilometer radius from the point that I specified.
We have
What you're searching for?
53 north, 113 west.
Yeah, makes sense? Okay.
What you're searching for? I mean, this is a location
Yeah.
nearby 2 kilometers around. What you search
These
for?
are all building permits, like I was saying. This is just a sample data set.
Oh, FT you're searching for.
Yeah,
Okay.
yeah, permits. So just building permits. It'll make more sense as I like show you not this giant crush of data, right? So find my mouse cursor. Let's make it a little bit more complicated. I'm going to then search for, this is just any building permit no matter what it said in it. So there was actually no full text searching here. I was just searching under this field, right? Now let's search for building permits that say the word deck in them. So like a patio. And I know it's way at the bottom. But, okay, so let's just execute this in, what do I do? I have PowerPoint starts again, converting quote symbols. Okay. So I'll show you this is the query that I did. So there we go. Okay, so I did deck. So this is the word I'm searching for in the full text search, location. So that's the only difference is here. And then I'm showing 85 results. And you can see all the different results we've got here. We've got 85 different things, and you can see it's all over the place. I can show you more. This is actually returning everything, so to construct, right? This is not very useful. So let's go ahead and just go ahead and take only certain fields from that, right? So again, I'm going to put this in here. And now it's getting to be a little bit more useful. So what I did here, so we're doing permits, deck, same query, but I'm just saying, let's just return some values. I got 3 values I want to return: address, description, and construction value. Okay? And that's the result set that we have. So if we look here, this is a document ID over here. And everything in RediSearch and most search engines have some sort of like document ID that reference that. That's kind of like almost a primary key if you're using that sort of terminology. Here's the addresses. Let's make this a little bit different. Okay, so those addresses. And the construction value is not very important. So, okay, construct 2-tier uncovered deck, blah, blah, blah. Not very interesting data. As you can see, it's pretty repetitive, right? So it's another important point in the search engine. You know, how big is it per record is what people always ask, right? Well, that's not the right question to ask because some of these things are going to have very repetitive words in them. You know, uncovered grid deck, it's going to add to a specific index. So what's happening inside is it's going through and it's tokenizing out or splitting out all the different pieces and then putting them into indexes and then referencing them back. So internally inside RediSearch, there is a construct set, effectively, that has like all the different documents that say the word construction. You can tell, because it's a building permits database that's giant, right? So you're really looking at more about the terms rather than the actual document size. That's usually more relevant. So let's make this a little bit more complicated yet again. Put this query in. Let's go look at the query. Okay, so this is the query that I'm running now. I'll make it go up a little bit. Okay, so search, FT search permits deck location, right? This is the same location, it's in 2 kilometers. Then I'm also putting a range of the construction value from $1 to $3,000, right? And so this has now limited the search. We only have 62 results. If we go all the way up here, you can see that we had 167. If we keep on going up, before we did things, we had 883. So we're narrowing in on some data, right? So as you can see, it's in no sort order or anything like that, but it's just returning all this information. And I'll again rearrange some things. And I'm sorting things, unfortunately. I don't need to do that using this interface. But yeah, looking at the constructor rear uncovered decks and boring information. So let's make it even more complicated, right? So in this case, I want to return the neighborhood, and the neighborhood is a tag value. Okay. So in this case, can everyone see this? Okay. So we have a neighborhood section here. These are the different neighborhoods: Blackbird, Twin Brooks, Keywind, Twin, so on. It's Bear Spa. They're all going to be one. They're going to be a few different ones because it's in a radius, right? So that makes sense. Steinhauser, all this different boring data that's probably not very relevant to you. But then let's limit by neighborhoods. So we'll go over here, do another query, and take a look at this. This query is even more interesting. So we have the same construction value limit from 1 to 3,000. The neighborhoods, I'm looking at just 2 different neighborhoods here. Twin Brooks is a tag in the Sky Rattler. Tags are a really interesting data structure in RediSearch, which basically allow you to have something that is very, very small in its storage requirements or storage needs, but it allows you to do some very limited things. There's no stimming or any of the full stack search things, but it's great for things like a neighborhood. Because you might want to, have some things might be on the border, so maybe it's multiple neighborhoods. You could say I want it in this neighborhood or that neighborhood. There's no need to stim it. Some really useful things, and it takes up about 1 bit per record, right? So it's pretty small because it's basically doing kind of like a bit field type of operation on it. So very, very small. It'll basically just put a check mark by it if you think of it that way. So this big record. Question?
The string deck that's searching all the string type fields is not going to touch the neighborhood. There's a neighborhood that has the word deck in it.
Right.
It's searching the ones that have string data types.
Yeah. So this deck, right? That is searching the full text fields, not necessarily the neighborhoods, right? It's certainly not the numbers. That doesn't make any sense, or the geospatial. There's some weird things in it, and this is like one of those, is it a bug or is it a feature? So this is something that we recently uncovered, and like I said, my friend Devere left, and there's like a kind of an interesting use case here. So these are 2 address-based, or full-text search fields, so address and description, right? And in the actual schema, if they're next to each other and you do an exact phrase match, it will actually like jump over fields. So if you were like searching Kyle Davis, right? And let's say the address ended with Kyle, began with Davis, it would be like, yep, that's an exact match. So there's some really weird things that occur. There's ways to control for that, but we were like, wait a minute, that's kind of useful. So we kept it in. Always the interesting things when you start discovering when somebody else leaves and you're like, wow, was that on purpose? It's useful. Somebody came to the use case and kept it. Let's make this query a little bit more interesting. Okay. So we're down to 29 results here. And so what I've done here is I'm adding a sort field, right? So before it was unsorted up there. Now you can see we're sorting it by the construction value. So we have this nice, neat, increasing amount by the construction value. So and the construction value is a numeric field, so we can do that kind of sorting quite efficiently. Okay, so everybody with me still? Make sense? Okay. Because the query, like I said before, is kind of shared between just the standard search and then also aggregations. So we'll go into the aggregations next. or we'll go into scoring, weighting, and sorting. Okay, so I do want to briefly go over this because it is important for some people, but not for others. Okay, so there's a couple different things. Every document has a score, which determines how the quality of it, right? So you might have a low quality one, you would put a lower document score on that. Then you have field weights, and a field weight would mean something, one field is more important than the other. And then sorting. These are all things that influence where things return in the result set. We use term frequency, inverse document frequency as our default algorithm. There's a few other ones. We have dismax, which is what Solar uses, doc score, and then we can actually have binary payloads in it, so you can actually do scoring through the binary payload, but not many can use that. It's a very specific use case. And then if you start sorting by a particular field, like if you looked at the previous example, I was sorting by the construction value, well that trumps everything else, right? So all things being equal, let's say you had, everything had a 500 construction value as an example, right? And then that's when the doc sort would come into play, and you're sorting between those, that one field that all things would be equal, right? So we have a lot of options here, and there's other things too where you can actually specify like optional clauses, which will actually influence things up into the different result sets. So if you say optionally, like before we were like optionally I wanted a truck or something, that would just kind of boost it up. Okay. Now we're going to talk about aggregations, which are really fun. So who does aggregations on a daily basis? Nobody on a daily basis. Oh, one person. Monthly basis? Keep your hands up. Daily basis? Some people do.
Sure.
Okay. Few people. Okay, so aggregations is not this crowd's thing, right? But still, it's really useful. Okay, so we basically have a particular system where we look at processing and transforming the result set. We use the same query language as the search. That's where it's shared in that Venn diagram. And so the basic building blocks are group, sort, and apply. And so you have this pipeline of composable actions, right? So this is just an example. You can have these in actually many different orders. Group by, it can have different reducers inside of it. It can have multiple reducers. You can apply different things which will transform. You can sort, you can see we have apply twice. So you can create these big, long pipelines of different transforms. You can do some crazy stuff with it. So I'll give you a couple examples of it, or maybe just one nice big example here in a second. So here are the basic reducers that we have. You know, you're doing counts, count distinct. My favorite is count distinct-ish. We're using a Bloom filter internally, so it's not exactly right. It's probabilistic, so ish. Summing, min, max, average, standard deviation, quantile. It's two lists, which is relevant, especially for our tag fields. First value and random sample. So these are all kind of functions that you can use for reduction. Manipulation as well. We have different strings. This is not exhaustive by any means, but you know you can do different things like this. The substring, upper. So it's hello world. We're getting the first 3 characters, then we're replacing it. That sort of thing. So that illustrates that it's actually like complete in the fact that you can nest things in, do all sorts of things with that. You can do numeric evaluation. So square root, log. You're flooring things, and you're doing all sorts of different crazy stuff if you so desire, and have built-in format support for Unix timestamps. That's how we kind of natively deal with time. That's pretty useful. So you can go in, and if you put in timestamps, then aggregations understand what you mean by that when you're doing that. So you can see if you actually format it. You can do the kind of Python-like time formatting there. So let's do it. This is one of those things where I feel like it's much easier if you see it done than actually understanding how it looks. The first few times I saw this, I don't know what's going on. Just to be frank. So let's go ahead and come over here, back to our familiar interface. Okay, so clear that screen. And paste in a big query here. So this might look familiar. Like I said, we're sharing these things, so we have our same query here. I'm looking for the DEX and the location of this in these particular neighborhoods that are under $3,000 but above $1. So what I'm going to do is I'm going to group by, and RediSearch uses this particular format where you have a group by, And then in anything, you'll see this later on with sum, we say how many arguments are coming after that? Well, one argument's coming after that. So then we have neighborhood. So I'm grouping by neighborhood, right? And then I'm going to reduce it to the sum, how many are there. And then I'm getting the sum of the construction value, and then as the total construction value. So fairly simple, right? So let's see how this looks. All right, so we only had two different ones in this particular query. We had Twin Brooks and Skyrider, which makes sense because we looked at Twin Brooks and Skyrider here. But I clicked it out and I looked at how it looks. So you can see the total construction value here was 46,583 versus 3,500. So if you wanted to see where the money was being spent, please take a look there. So let's go ahead and take out that. Well, this will be a little bit more interesting if we take out our neighborhood reduction, our neighborhood limit. Okay, so now we have a few different ones. As you can see, it's all going through in the map. Yeah.
Why is the neighborhood lowercase?
The neighborhood, okay. The neighborhood that's how it's stored internally. So if we're looking here up there, that's just, it was all in caps. So its internally tags are not case sensitive.
Results were attached.
Yeah, they're not. They're not in the aggregation engine. It's not relevant. It's just one of those weird quirks, right? It's stored, I think the way it's doing it, if I was to go and look at I'd have to go and look at the C source code. But what's going on here is that it's reducing it. There's an implicit lowercasing going on for the aggregation engine. Yeah.
You also get a shirt. So anyone that, asks a question or, makes it really interactive, you get a shirt. Yeah.
Oh, for sure, I have a question. Why the function to
And the question, sorry, I didn't get that.
why the function on aggregate framework toLen is not underscore when the other function that consists of two words underscore?
Feature. I don't know.
I just want to make it sure.
No, I honestly, I do not know the choices being made here. But I can say that there's some quirks that will go and alias it, so it makes sense. So let's take a look at, let's make it a little bit different. We're going to take a construction value. I'm just going to kind of like reverse what we just did, just to start showing a little bit different. As you can see, we're calculating things out. If we look at Twin Brooks as an example, 46,583, and then, wow, Twin Brooks went out. Well, what happened is I took out one of our terms where I said construction value to 1 through 3,000, right? So you're seeing the query affecting the aggregation. And then we can keep on going out. And if I was to go all the way out, it would probably start getting, take a look at deck. This might be you have to have certain fields that are sortable and not sortable in the aggregation.
I'm sorry, what would happen if you say instead of 1 you add 2 and put something like average?
Okay.
So the sum is really aggregation average.
Yeah.
Makes a little
Yeah, I can do that. Yeah. So let's do that. AVG. There we go. So we're averaging it. So that's the average based on the count. So there's all different functions. This is just an example. And we can go ahead and do some more interesting things. So now we're just looking at decks over 10 years. This is probably going to be a little bit slow because not all these fields are actually sortable.
Okay.
So now we have all the results here for every single neighborhood over 10 years, and you can see the average value or the sum. So that's the aggregation engine. You can do some really interesting stuff with that. And then let's go ahead and talk about, let's change gears just a bit, and talk about Autocomplete. So like I said, Autocomplete is completely separate. It's sometimes called suggestion. It's in the module, but it's completely separate. It could be in its own module. It's based on a radix tree. Very familiar with the radix tree format, or I guess that structure. And so it kind of uses this tree-like structure to find things. So it's actually quite quick to go ahead and look at these. So as you type completions are completely reasonable to do. So you have just a few different things that you can do. You add a suggestion in. You get a suggestion or you remove a suggestion, and then you can specify a score that you can increment, right? So in this case, if you want to increment a score, let's say that this is more important, it's getting more results, then you can increment that at a later point. So you would return a more relevant autocomplete. Let's do a short demo. This is the one that I was definitely writing yesterday afternoon. And this is based on just the addresses. So And I don't have a cheat sheet here, so I'm flying by the. There we go. So this should find all, and it's going to return automatically 5 results, right? So I consider it to be more, but this 5 results is a reasonable amount for an autocomplete. So I'm starting with A, right? So this is the address, so it's like A. Well, the address, there is one address, there's A Street, Avenue, Austin, Abbott, and Agar. So that's, in theory, someone was typing A. Then if we go through and we do AB, right? So let's say we're actually looking for Abbott. We can see we're getting Abbott in Abbott's field. And you can go on different things. If I was to do AG, I just clear this out first so you guys can see it. AG, we can see Agar is the only thing we have, so on and so forth. If I was to do J, we have Jasper, J, James, G. And these are based on the frequency that it occurs in the data set, in this case. So JA, this will return only ones that start with JA. This is just useful things, right? This is something if you wanted to go and create an autocomplete widget on a particular website, this would be a very easy thing to power it. But it's completely, in this case I'm using the same data set, but it's completely separate. So you can create different auto suggestions. So, yep.
Is the result always come back in 5?
Yeah, that's the standard. You can actually set a different amount. The max I think is 20 for this, but yeah, 5 is just the standard. Yeah, default. Yeah, and that's just a reasonable amount for an autocomplete, right? So you wouldn't want to return 1,000 results for autocomplete. That wouldn't be very useful. So it's really pretty easy to use too. I mean, this is something that I feel like we should have packaged maybe as a separate module and then use them in concert. But I think it's great to have it as to go along. So that is the 3 main features of RediSearch. And at this point, we've taken some questions. I want to open up the floor for more questions. I see lots. Okay, I'm going to talk to the engineer. Yeah.
Oh, thanks. When you loaded the initial data set of all of these permits, right?
Yep.
Did somebody create a schema because it knew which fields were which?
Yeah, there was a schema, and I could I'll actually do that. I can switch over to the FT.
How many fields were?
Okay, so this is just some data about the thing. You know, how many permits we have? 121,828, and this is the fields that we have. So we have permit timestamp, which is numeric and sortable. We have job category, which is where I'm not stemming it. It's text type. It's got a weight of 1. The address, same type. Neighborhood is a tag with a separator, and it's sortable. The description here is, I'm using weight 1 for this particular one, but building type is weight 20. That's actually a little bit different. So that's a more relevant type thing if you were to type in building type. Yeah.
Part 2 of the question would be, what did you use for key?
With the key?
Yeah.
In this particular data set, there was an actual canonical, this is the one permit. It's got
a permit number?
Permit number. Yeah.
And that was the key?
Yeah.
Okay.
Yeah. You can make anything you want to do there. Go on the back.
On the autocomplete, is there any fuzziness to the matching? So if you're searching for Abbott and ABO,
there's a way to do Levenshtein distance,
right.
Built-in LD1. If you want, you put percent signs around it.
Okay.
Yeah. And then of course you get some stemming and that sort of thing. You get some fuzziness that's automatically built in that's based on what you're searching for.
This is the index you're showing. Do you have really where the data stored? What is the data? Do you have one table, many tables?
Yeah, so the concept of table is not something that RediSearch has. It's based on an index, right? And the index does store the data in it. So it's all stored in one index. And if you take a look at the key space for Redis, it's actually quite interesting. Most things with Redis use one key per piece of data. So you have a sorted set that is all under one key and it's got many sub-values into it. RediSearch actually distributes that out so it's be able to use on a cluster, so it will actually be able to be shardable out to different clusters in the enterprise version.
What is the relationship between space and RediSearch?
Yeah, so that's a good question. Apologies on that, I didn't answer that. So Redis is extensible through a module system, and RediSearch is a module. So the module system allows you to create first-class citizens on the commands in Redis. So in this case, the module is RediSearch, and it has new commands which are implemented, new data types on top of the existing Redis system. Yeah.
Let me follow up with, what if I have an Excel sheet or existing table?
Yeah.
How do I load it?
Sure. I can show you what I did on this. I built a little ingester for it. So it takes a CSV file, and it just puts that CSV file, it streams the CSV file and starts adding them in at the same time. So that way it's 25 to 40 lines of Node.js code to do that. It would be specific because you're trying to build the data for that schema, right? So you might do some minor manipulation. And in this case, I'm using JavaScript, so I'm coursing something from a string to a number, as an example.
And this is what I see out there loading, is that right? This is all what I see?
Yeah. So this is, I will say this is, I'll show you this is just something I built. This is the interface. But if we go ahead and take a look at, see if I can actually pull all these over to this again, my problem over here. Okay. So Redis CLI, put in my password, Redis is cool, and clear this. I can clear that one. So you would actually use this type of interface. So I do ft search permits, deck, right? So this is the very fundamental interface, and there's programming language client libraries that would allow you to use this in any language you're using, Python or whatever.
Going back to the index question, you mentioned that you can do secondary index searches, but I missed it. How do you do that?
Yeah, okay, so you're saying, when you mean secondary index, you're meaning like you want to store something somewhere else? Is that the way you're meaning it?
No, I want to be able to index it on secondary key. So I have a primary key that I can index on, but say I want to do a subgrouping and I want a secondary key to do that.
Yeah, so that's the fields. So you can actually search on the fields. That's what we mean by secondary indexing in this circumstance.
Oh, so the fields are also indexed?
Yeah, everything's indexed.
All fields.
Yeah.
All fields are indexed.
Yeah, all fields are. Yeah, go ahead.
Okay, I assume we have relational operators and numeric fields.
No relational, we're not relational. I want to be clear.
So I cannot say like this is less than 20,000 or something?
Oh, of course you can, but relational as far as multiple tables is what I'm speaking
of. Okay,
yeah.
I mean, I'm not asking John. Okay. Do you have any feature that I can say like list all the values until their sum is a million?
Like you want to say between up to 1 million or?
No, this time we tried sum and average.
Yeah.
But what my question, I intended to ask was, like, is there any way I can limit it? Like when the sum, you list some 10 or 20 values until their sum is less than 50,000.
Yeah, so that would be the limit, right? Like, if I'm understanding the question.
That would be the limit? Okay.
Yeah, it's just, let's take a look. I actually went through this. Let's go back. So in the search, this limit 0 to 85 is from the 85 results. Is that what you're referring to?
Okay, I was wondering like the sum of some field.
Okay.
The total comes to some number.
Okay, so you want to show only if the sum is greater than 1 million or something like that in the aggregation system?
Yes.
Yeah, sure, that's possible. So what you would do there is you would do another, if we take a look at the aggregation, right? So like I said, you could do multiple different pieces in the pipeline, right? So this is total construction value, right? You've calculated that. In this case, I was actually averaging it because that was a question mark. And then you would say, you would go through and you would actually, let's see here, how would you do that? There's a way to do that, and I'm blanking right now on which operator, or which one I would do. There is a way to do that. I'd have to look at the documentation just briefly, but yeah, I've done that before. I'm just blanking at the moment, right? Get with me after the,
I'll
show
ask
you.
you after that.
Yeah.
Okay.
Yeah, go ahead.
So what's the computational load that RediSearch puts on a Redis database?
Sure. It's heavier, right? Because Redis is generally working with smaller values, right?
Yeah.
And we decided to make this quite scalable. So everything is written in a way that would be as efficient as possible when it comes to the sorting. Like we're using very modern sorting algorithms and that sort of thing. So like I said, with tag values, we reduce it down to 1 bit per representation of tag values. So when it's going through and sorting, it's going to take care of that for you. As far as like the actual computational, like big O notation, I couldn't tell you off the top of my head. But it is considerably higher than what it would be in Redis, right? But what we have done is made it clusterable, so you can spread that load out over multiple different nodes in a cluster. So the computation would occur in parallel across multiple nodes if you're doing the enterprise version. Okay, Blucher.
Is there any performance analysis like graphical way presence of how long it takes the queries?
Yeah. So if you want to see like how long it would take a query for like this particular query, how many milliseconds it took or something like that. Yeah, certainly that's something that we don't, it's not built into the actual search engine itself, but you can certainly measure that in the client libraries. And we do that with our benchmarks. For example, we'll go in and say, how long did this query take on average? We run it 100,000 times or something. And then we do keep track of any slow queries that come up through a slow log internally to Redis. So if, let's say you're writing something that seems to be taking a long time, Redis will internally keep track of the longest running queries, just so you can debug those. And that's called a slow log. And I could run the command if you're so interested, but it's not very interesting on a test thing. Yeah. Richard?
Yep. Follow up on the question. You list JSON support. Is that like a first-class citizen? So that relates to my other question. Can you do like a secondary key search within a document object, like a JSON?
Yeah. Okay, so JSON is not supported directly in RediSearch. And when I'm doing this, this is just all interface that you're seeing here. So that's you know, like if I go do this, then I'm looking at this array, like that's JSON because that's what I have taken through and put it into when I wrote a little JavaScript connector. So that's not necessarily RediSearch. Redis does have a search engine or a JSON module, just like RediSearch is a module. But they're two separate things, right? So natively, RediSearch does not have JSON at the moment. It's on the pipe. It's on the long-term list of things to do, but it doesn't natively have JSON at this point. So we have questions up here. Richard?
Yeah, so how would you implement text clustering, like for example, if maybe there's a lot of permits asking for debts, and maybe a lot of permits asking for citing.
Yep.
And how would you implement text clustering?
In aggregation or in search?
In RediSearch.
Yeah, in search.
In the database, so like tell me, give me the three biggest clusters of types of permits that have been requested.
Yeah, so there's a couple different things.
Means clustering, for example.
Yeah, I actually understand. There's a couple different things you can do, right? So one of the things you can do is you actually can go in and use the slot feature, and then so you'd say like deck and so, right? If you just wanted to find two different things that you know ahead of time, and then you would go through with the aggregation engine, and you would then put that through, and then where deck and this occurred, right? So you'd be able to construct your query kind of like that. There's another thing where you can actually go through and attribute a subclause to have more weight than another subclause.
What if I don't know what the clusters are ahead of time?
Yeah. So you just want to find like where deck and I don't know lantern are together. Now it's not something that's necessarily built in, like that sort of feature is not something that's interesting.
Is there a way to access the TF-IDF signals directly, for example?
Yep. There's a thing called width scores, and it will tell you the actual score that comes out of it. So, and in fact, I can do that. Let's put this out here. And this is something that's used primarily. It's going to be really, it's nasty because I haven't built my little thing for it. I'll do it over here. Deck width scores, right? So now we're seeing the TF-IDF score here, and this is the score that's calculated through TF-IDF. There's a couple little optimizations we have on top of it, so it's not pure TF-IDF, but in this case we're getting two here because I don't know, deck, detached deck and deck. This is actually the score. Other questions?
Do you have any example applications that use this stuff in a higher level?
Yeah, sure. So there's a major financial institution that uses it, which I can't say their name. You probably know about them. It's used in, I'm trying to see which ones I can name. There's some that we can't name for various compliance reasons. There's a startup that does like vinyl record searches in Europe who's doing it. We have a major hospital on the East Coast uses it. I can't, some of these I'm not required because I don't have the rights to
Sure,
say.
so those are kind of companies, right?
Yeah.
I'm talking about a more specific application, like, let's say I wanted to index all of my PDF files.
Yeah, sure.
Can you do that?
Yeah,
And then can you combine them with web search results?
right,
And
right.
then something else, right?
Yeah,
Aggregate.
yeah, good question. So we have a few different things that we've done. One of the things we did was, like, at our actually recent conference, I live searched all the mentions of Trump going on Twitter through the Firehose, which was interesting, right? So that was just a plain search example. We've done, these are some of these, I'm just saying the example ones that I can tell you about, because some are customer ones we can't. I don't want to post through too. We did Reddit comments as they came in as well. Our website Reddit. It's a little bit tough because it is quite new. It hit 1.0 in November. So, you know. Yeah, right. I know, November seems like yesterday. But Aggregations is new as of April. So.
What about like a chatbot?
Yeah, sure, you could do that. There was a company called Vidi who went out of business, unfortunately. They were using some of the earlier versions of it. And they were using it for, I believe, do you guys remember? My understanding was they were using it to index closed captioning as it came out. So like live closed captioning. So don't quote me on that, but they're out of business because it doesn't matter. Other questions from that?
So do you have benchmark, compare this and relational database like MySQL?
Yeah, relational databases are not really relevant, but Elasticsearch is a good comparison. We use Elasticsearch. We're about 5 times faster than Elasticsearch. So it's based on, it's the fastest of the breed. It's based on Lucene. So any other Lucene-based search engine, Solar, or whatever.
So Solar and Elasticsearch is about the same compared to RediSearch?
Yeah, I mean, generally Elasticsearch is faster than Solar, right? In most workloads, and we're about 5 times faster than Elasticsearch. So that's just been the primary benchmark we've worked against.
Is there any difference in the concurrency, like the number of clients, for example?
Yeah, we scale pretty much linearly when it comes to, we inherit kind of Redis scaling. And so we don't bog down as the number of clients connect, right? So that's one of the common problems that Elasticsearch has, is that as more clients connect, it becomes slower and slower and slower. And because we can scale more linearly on that, you can connect different nodes. And there's a slide that I don't have in this deck, but it kind of compares the two, and you can see Elasticsearch is doing this, and we're just kind of flat as far as response times.
So in terms of the curve of performance versus
quote-unquote
hardware,
if
you're 5 times faster than Elasticsearch, is that based on the same hardware?
Yeah, same hardware.
Configuration?
Yeah, same hardware, same configuration. One thing we do is when we're doing the benchmarks, Elasticsearch has some very aggressive caching in it, and caching is not, it's not, we usually turn the caching off because that's not a fair fight necessarily. That's measuring caching, not measuring search ability. But yeah, donuts for dollars, same information, same AWS VMs we're comparing that.
But your database in the memory, all in memory, how do you say about cache? That's basically, everything is cached, right?
Well, not necessarily cache, I mean, it's live data, right? But it's about the search, like how fast can you index, like how fast can you ingest documents, and then how fast can you query, which are things that we were looking at. And it's relevant that we're doing those things. And so, yes, of course, when you're talking about the amount of storage that you need, that's a different type of storage that you need, but CPU power, when you're looking at the same CPU. Other questions over here? I feel like I've been in more insider. Yep.
Question, so you have this database permits, right?
Yes.
But if in terms of streaming, so can I replace the permit to like a channel so that I can subscribe and automatically I can filter the information in real time? Is that possible?
I'm not sure if I follow the question. Of course, permits is just, this is a sample data set.
Well, that's a database, right? But I'm talking about like in streaming mode.
Oh, okay. Yeah.
Can I apply some kind of query right there?
Yeah. Okay, so, you're ingesting documents, they're available for search within 1 millisecond. right? So as documents come in, certainly you can immediately query on them, but you can't necessarily say when this document comes up that has the word, I don't know, grill or something in it, that it triggers something. That's not in the feature set. So that's just not something that we do. Redis has some ability to do something like that. We have a couple sub functionality, and we have streams in Redis. Those aren't necessarily built into RediSearch though. They're kind of two different things, two different functionalities. We're kind of a multi-model database, and those are two distinct models. Any other questions?
Do you have default timestamps? So I want to see what are the latest thing, or should I add it as a column in the...
Yeah, we don't have default timestamps. It's not something you can just say like the current one. And we do that on purpose. When we're in clustering mode like that, synchronizing timestamps is just don't do it, right? Like that's the best thing I can tell you to do. And the other thing to realize, and this is a search product, right? With search, you're not necessarily, I would not make it your primary database, right? This is something that takes the existing database and then it provides extra functionality on top of it. Maybe you can rebuild the index at another time and that sort of thing. So I wouldn't rely on that unique piece of data being generated by the database. So go ahead, if you have like a SQL, something that you want to do your slow queries on or whatever, fine, just do it there, and then we'll take the data and make it really accessible in different ways. So you can use them together and in concert.
Is Amazon have this on their service, AWS service?
They decidedly do not. So yeah, this is something unique to Redis Labs, and Redis Labs offers Redis Enterprise, which is available. You can put it on Amazon certainly, where we make it available in the Amazon Marketplace, and it's fully able to be run. We test everything in Amazon EC2 instances, but their Redis version is called Elastic Cache, and they do not have that by purpose. It is something unique to Redis Labs product. So that the licensing model does not allow them to do that. RediSearch is open, but the clustering system is part of our enterprise product. So you have to purchase the clustering part as part of enterprise.
So this is not a relational database. There's some kind of advantage over relational database. What is a typical application I can use instead of it?
Yeah, sure. So the differences are with something like an in-memory database, NoSQL database, both parts of that, is that with this you're simplifying the whole structure, right? And we generally get much faster throughputs. 50 million outputs per second at sub-millisecond latency, which is very difficult to achieve in a SQL database, right? So it's about simplifying it both from the operational part. And, you try to achieve those levels at SQL. It's kind of hard to run with any type of SQL database. And from a development standpoint as well, it's going to be a lot simpler to write. I mean, I used to work at a university and I wrote page-long queries, and I don't do that anymore, and my life is better. No one really likes to maintain a page, 2-page, 3-page long queries, right? That's just that becomes madness after a while. And that's the whole idea of NoSQL, is that you can kind of abandon that complexity into something that's a little bit more simple. And you can have a different data model that just does it.
Yeah, your query may be simple for you, but for me, look, this data doesn't make any sense to me.
Okay.
Yeah. This data structure doesn't make any sense.
This, you're showing it here?
Yeah.
Okay. It's just a return result. And what happens mostly, and it's just interleaved, right? So the permit timestamps here, the job categories here, so it's one after the other, right? What happens, this is like a crude debugging tool. If you go ahead and bring this into, and the other thing is that most of the time when you're going through and you're actually using this in an application, in your application you're going to have some niceties that will turn that into whatever is native for your particular language. So, for example, I work with Node.js quite a bit, so it turns it into a JavaScript object for me inside an array. So if I worked in Ruby or if I worked in some other language, it does some of these things. The client libraries tend to make them into something that's more digestible.
Can you make this as a MySQL table?
Nope. Let's just say that's not a great idea. No, you could, if you wanted to, if you really, really wanted to, you certainly could write an update query or whatever, an insert query to do that. I think that would be a bad life choice.
Yeah, I know you showed us, the schema earlier.
Yep.
But But that was already there, right?
Yeah.
Did you show anything? I must have missed it. You actually make like a new index? And
I can show you what it is, and probably it's better served by the website than me typing it in because it's quite lengthy. So, I'll tell you what, I'll bring up my source code. Okay. See if I can drag it in the right place. Okay. This is the code that creates the schema. So it's basically the same thing. ft-create creates the schema. My IDX is the permit's name, it's just a variable. Schema, permit time span, it's numeric, sortable, job categories, text, no stem, so on and so forth. This is where I create the schema. And this is just in a Node.js application. And it's not very long. The whole thing, including like a little thing that shows bar graphs, is 160 lines.
Oh, so you make the schema in the in the application, like at the start or something, and then you use it.
Yeah, you can type it in if you want to. It just becomes very long to type
Okay.
in. Yeah.
So it's not like an integral part of like the RediSearch configuration when you boot it or something.
Yeah, no, it's generally something you do at the application level.
Okay.
That's the whole thing. Like if
I
you're
get
coming
it.
from a SQL background, you're used to creating that sort of thing. And
Yeah.
That's not generally what we do. As you can see here, this is all like JavaScript stuff that's actually handling like bringing things in, but the actual meat and potatoes of the streaming parser to do this is a 30 or 40 line JavaScript program. So I just made it look nicer and put some metrics in.
Okay.
So yeah.
And I guess so it's a Redis module, right?
Yeah.
So that means it actually runs in the same process as the Redis process for that node, for that server or whatever.
Yeah. So the way it's written in C, right?
Yeah.
And it's an you write it as a shared object file. You compile it, and then at runtime, Redis can load it, or you can have it at start time, either way. And then you have it suddenly like gives it all the power of RediSearch from being just a normal thing. So they run in the same process, but I will say there are parts of this RediSearch that are actually Redis is known for being very quick because it is single threaded, right? And we achieve multi-threading through clustering. However, RediSearch does employ more multi-threading than Redis does. That's why there's some careful language when I say like it's 1 millisecond from the time that you add the document to its searchable, because there is a second thread that's doing that sort of stuff. So there is some differences here and there to maximize what we can do. Redis was never, when it was created in 2009, ever designed to do anything like this. So we had to actually kind of work around some things, expand some things. And in fact, this is one of the reasons, this is one of the first modules that was created. And modules have been around since 2015 as the very first kind of preview release of modules. So this was one of the very first ones around, and it really was developed mostly in 2016, 17. No, 17, 18. What year is this? No, 16, 17. Yeah. Other questions? Dave?
I was just curious, based on your experience with Redis, like, are there any elements in here that you think would be better taking more advantage of Redis?
Okay, in RediSearch?
Yeah.
Yeah, well, so one of the things that sorted sets are an example in Redis